Hello, everybody. My name is Jack Lazarchak, and I'm a developer at Chariot Solutions. Serverless. This is a buzzword we've been hearing more and more in the last few years, but what exactly does it mean? You'll certainly get different answers depending on who you ask, but most would agree that it can be a very useful tool, especially when used correctly. As with anything in technology, there's advantages and there's disadvantages. Here to teach us about all this and more is Director of Training and Mentoring at Chariot Solutions, coming to us live from his car, Ken Rimple.
Thank you very much.
Before I hand things over to Ken, I'm not done yet, Ken. Sorry. Before I hand things over to Ken, I'd like to take a moment to thank the audience for being so flexible in dealing with the conference changes we've had to make. I'm very glad this is still able to happen, even if we can't meet in person at this time. And actually, all this would not be possible without our next presenter, Ken Rimple. He puts a ton of effort into this conference every year. So a big thanks to you, Ken, and a big thanks to everybody watching.
Thank you very much, Jack. All right, well, thank you everyone for attending. I see we're headed up towards 100, which is great. So yeah, today's talk, I gave it a very kind of silly title, and I didn't pick this recently. I actually picked this back in, I think it was December or January when I selected the talk, Serverless, Schmerverless. And there's a reason why I do that. If you've done any experimentation with serverless frameworks, you either end up in a puddle on the ground in about an hour, or you suffer through it and you notch your belt every single time you learn a new feature. So this is my search for knowledge. At Chariot, we constantly look at new technologies. I was one of the first people to look at single page applications way back and really focus on AngularJS and then Angular and React. And so the only way around it is through it. You have to try to write a lot of code and write a lot of broken code. So my goal was to do the same thing. So that's what this talk is about, is to just try to figure out for a new developer going into it, what does serverless mean? And then what are some of the technologies and tools that people are using in serverless, and specifically serverless with Amazon Web Services, although a few of these things can apply across the cloud as well. So yeah, Jack did a great job introducing me. I really appreciate that. Right now, what I'm mostly doing, I just got done with a very large project for us with a team that was Docker-based on AWS back in November. And since then, that's when I've been focusing on serverless. I mostly focus on front-end applications in React, Angular, and a little bit in Vue here and there. But I write training in it. I consult. I get our consultants up to speed quickly in some things. And I'm part of the management team as well. So help, put together the projects and see them through. So let's start off by talking about what serverless development or serverless software development is. First of all, as I mentioned before, it is difficult to master. It will take you time. You can't just assume that you're going to take a week and learn everything there is to know about serverless. You could say that with things like Rails to get started, and everyone who's done a lot of Rails will laugh at me for that. But to get started, it takes a lot more than a week with the current technologies that are out there. And part of the problem is that there's not a great getting started story for a lot of these things. There's a little bit of tutorials, and they just get you just close enough to the cliff edge to say, take a look down there, and then you fall. And then you wonder why you're doing this after 12 hours of digging into something you have no idea what you're looking at. So there's a real challenge there for serverless where you get these little tiny tutorials that get you somewhere, and then there's a vast gulf between that and getting something real done. The other thing is a lot of the tools we're going to look at today are very, very leaky abstractions around the guts of putting something together on AWS. You'll notice that we're going to talk about CloudFormation. A lot of these tools directly use CloudFormation. They help you write it, but they use CloudFormation anyway. So how much of an abstraction is it really? And even if it was an abstraction that helped you for a while, you still have to open up, the hood and look under the hood and check the oil, and you're going to be dealing with AWS primitives. That's actually okay. In fact, all the other things you're going to write in AWS, you're pretty much going to do with something like CloudFormation anyway. So it's a good thing to learn. But they are leaky abstractions, except for one of them is much less leaky than the others. And you're fraught with a lot of complex choices for configuration. Security is a really, really big black hole you can spend a lot of time looking through. For example, if you've ever configured cores on API Gateway, you'll be nodding your head right now and probably pulling your eye sockets out to check to see what's behind them. So it's a lot of complex configuration for the beginner. Oops. So why do it? And I have to thank Martin Snyder, who jokingly gave me this great emoji that is now in the ETE Slack as : slam : move quickly and get stuff done once you know it. Once you know it and you've built a couple of them, certainly, but it's going to take a while to get to that point. The main reason for it is to avoid paying for idle services and idle servers. Serverless means basically that it spins up, Amazon, for example, spins up the services as you need them and then releases them back into a pool of available services for other customers to use. So things like Lambdas, for example, if you're not executing a Lambda, you don't pay a red cent for it. If you decide to scale up and do thousands of Lambda executions, you'll pay while they're running. And when they all get quiet again, you're not paying for them as soon as they're done. That's the real promise of serverless, is that you're basically running functions and services that don't make you pay for them when you're not using them. And then because serverless basically hides things from you, so you don't think about it, you're not managing an operating system or an application server. And it could have lower costs than a legacy application based on that. But remember, you have to write the code too. And so until you get really good at writing the code, the cost of development may eclipse the cost savings you get back for running the serverless app if it's, not that commonly accessed, or it costs a lot to do the development. So we have a couple of options for building our serverless stacks. One is, and I've heard this from Cherry developers as well as others, well, why don't you just build this with CloudFormation or Terraform directly? You could. It's going to take a lot of time, and we'll see an example of that. However, it is the most native version of rolling out cloud configuration. I'd put CDK in there as well, the new Amazon SDK for doing the same thing as CloudFormation, but in code. You can use Amazon's framework, Serverless SAM, Serverless Application Model is what that stands for. And the Serverless Application Model is something that you can certainly work with that make it less configuration that you are responsible for. There's a framework that used to be out there called JAWS. It's called the Serverless Framework now, and that's kind of a cross-cloud toolkit that will also work with AWS, and that's another option we'll look at. But again, all of these are pretty much, they're relatively low level. Using CloudFormation as the lowest level, AWS Serverless SAM is a less low level because it does some automation of some of the tasks for you. Instead of building 6 things, you'll build 1, and it will build the other 5 behind the scenes. The serverless framework takes a tack of giving you kind of a language to work with that simplifies things a little bit more, but also adds its own kind of interesting problems to it. And then when we get to the next one, Architect, that's an even stronger abstraction, which tries to keep you productive, building as much business logic as possible and worrying less about the boilerplate. So that's where we're headed in the next, almost hour. So do you want to go serverless, or would you rather stay Schmerverless? Would you rather stick with something else? Let's kind of compare these. So on the left, we have EC2 applications. They're virtualized servers. It's easy to pick up existing, instances, maybe of a VMware vSphere instance. You can actually port that into an EC2 instance and run it. If you're used to dealing with virtual machines and putting a whole stack on a virtual machine, go ahead. It certainly is an option, has been forever. They can be costly to host. Primarily, it's because you may over-provision. So you might set up this elaborate multi-server framework with load balancing and pick very large machine instance types and find that you're paying a ton of money to host 15 web service calls an hour. So there's a lot of effort you'll have to take to tune this, and all of these that follows. But you can easily over-provision, and if you're not using auto scaling and load balancing through an auto scaler, you might be paying too much. You might also be picking the wrong type of instance, the wrong cost model. So there's a lot there. There are a lot of knobs to tweak. And also, you're responsible for keeping the operating system and your platform patched. So that's a lot for you to do. And it can be cloud agnostic if all you're doing is lifting your virtual machine up and hosting it in the cloud, and maybe pointing to a database that you can also host in the cloud. You can use EC2. But a lot of the world moved on to container applications with Docker or Kubernetes. And so Amazon has that as well available. So, Those are smaller services. Usually each of the Docker or Kubernetes instances are engines that do one thing. So you'll have a web server that exposes some REST endpoints, or you'll have a queuing system that exposes a queue, and that's all that runs in that container, and then you can scale those up. The project I just got off of, basically we did that for an Express server, and we scaled that up to as many instances as they needed, but it was done in Docker containers because we knew we wanted to have that very quick, low latency access to a running server. So these, again, are like EC2. They're running servers. They're small, tiny, targeted containers instead of full-on servers. But they can also scale up and down more quickly than a true virtual machine because they don't have to boot a giant operating system. And Amazon has a feature for both ECS, which is the Docker version of the container system, and EKS, which is the Kubernetes system. They have a tool called Fargate, which is a very quick runtime that's ready to go to very quickly ramp up your instances and ramp them back down just as quickly. You can also be cloud agnostic with that. You can even develop locally on your desktop with that. So there's a lot of advantages once you learn some of the things that take a while also with containers. Once you learn the techniques of creating a container and starting a container and communicating with it and setting up the stacks of containers, you can be very productive and cloud agnostic to a degree and run it all locally very easily. And then we have the serverless apps to the right, which are functions in the cloud. You got a runtime that's managed by Amazon, which means you really don't have that many things to twiddle. In fact, with Lambdas, you literally have 2 or 3 things you can do. You can increase the amount of memory you have for the Lambda. You can tell it how many concurrent instances you're allowing, and you can do things like keep them warm, which is keeping them running so they can run quickly the first time that you access them. And that's most of the tweaking you can do. Beyond that, the operating system, the environment, the SDK, the everything around it, that is all handled by Amazon. You don't even think about it. You only pay based on usage, as I meant before, but you're also very tightly locked to AWS. So Lambda functions, let's take a quick look at those for a few minutes here. So Lambda functions have a pretty common signature. It's a function with an event passed to it and the overall context of the environment passed to it. These events can come in from web services. They can come in from all sorts of different things, but we'll look at it mostly from like a REST endpoint perspective. So this Lambda here is expecting to return a web status code of like 200 and some sort of body to it. When you deploy a Lambda, it gets uploaded, usually to an S3 bucket, and it has a Amazon resource name, an identifier that you can wire into other services to connect it up. Your general goal here is to then take that Lambda and do things with other serverless services wherever possible. And the reason for that is because they should ramp up quickly and you only pay for what you are going to be using them for, and then hopefully they're done. You could access services that are server services like RDS databases. That's their Amazon's hosting for databases. But you may pay a penalty for the connection time to connect a real connection to a database that's not already pre-provisioned, unless you install something like the RDS proxy, which was created for that purpose for serverless services. So this is kind of like your front logic for your cloud infrastructure if you're using them for HTTP. And so your goal there is to make sure that you do all the front end logic and then delegate off to something else. And Lambda runtimes can run on a lot of different platforms. So Python, Java, Scala, whatever, and Node are pretty common. Different runtimes take a little bit longer to spin up an instance. So you'll want to experiment there. Keep in mind that Lambdas are used for basically 2 major purposes. One for asynchronous events, and then they're now being used for applications as REST endpoints. If you don't have a latency concern, you want to execute something kind of that's been queued up, don't worry about all that stuff. Pick the language you like, use it. Do whatever you want, but focus on performance, obviously, and how much cost you're going to spend. But if you're going to be pointing it directly to the web, you really want to optimize that Lambda and do as little as possible with the least amount of memory used and the least amount of libraries used as possible, because it takes less time to spin up and execute, and it will cost you less. So remember, serverless doesn't mean no servers. It just means not your servers. And so Lambdas usually access these serverless. environments. So the division of labor here is interesting. Your job is to deploy the Lambda code, and then Amazon will launch it for you. You ask for your Lambda to be invoked either by sending an event to something or by hitting a web service, and Amazon will fire up a container for Lambda. It's actually the Firecracker virtual machine that they use, and it's a really, really fast machine. They basically attach one to you, and they execute your Lambda in it, and then they detach it from you. That's generally the way it works, unless you're holding on to them for a period of time. And they will keep them around for a little while. So if you then hit the Lambda again, it will be pretty quick compared to the first initial call. But that's all Amazon's job, is to actually manage that for you. You can give it hints, but beyond that, Amazon takes care of that. You do have to define the identity and access management roles and permissions so that you can attach the Lambda to something that's trying to execute it and give it the rights to call the Lambda with an execute call. Then Amazon will take care of protecting it and will follow your roles and permissions. By default, nothing can access the Lambda. It's just there. So you have to attach it to something to make it run. And you do that by mapping it to events. So one of the things you do on the left here, the map of Lambdas to events, is you map it to an API gateway deployment. The idea there is that you map out your URL, your path, your URL, you deploy something that is an API gateway front end to it, and you say, I want this particular path to execute this Lambda. When you do that, you're going to attach the role you've defined to execute the Lambda so you can run the Lambda from the API gateway. If you have security concerns, you're going to have to set up some sort of security, whether it's driven by your application, or if you're using like a open source, open authentication security authentication mechanism. If you use Cognito for that purpose, you configure it, you define it, you deploy it. And then once you wire up your API gateway, for example, and your Lambdas in the API gateway to that configuration, then Amazon will follow that and protect your app from not being properly accessed. If you forget that stage, if you just basically wire up an API gateway, you make it public, and you give the API gateway execute privileges to your Lambda, then anybody can trigger your Lambdas, attack them, and run up a bill. So you just have to be aware of that. And then, as I mentioned before, you can do things like setting the memory needed and timeout and how they're warmed up. The one thing you have to remember about Lambdas is everything you deploy is basically a single-threaded thing by default. So when you execute a Node.js method, JavaScript method Node.js, you'll only ever get one CPU allocated to that call while it's being executed, at most. And I believe the amount of memory you have to set for that is about 1.5 gigabytes of memory. As you slide that down, 256K, whatever, or 256 meg, I should say, you are getting fractions of a CPU's time. So if you've got a small method that does barely anything but kicks off a call to a database that does all the work, you could give it relatively low memory compared to if you're doing a lot of CPU intensive processing and running up a bigger bill in the Lambda stack. So yeah, Lambda functions connect to API gateway. You can use load balancer, like application load balancer, to map them as well. And they're basically microservices that you could use to replace monolithic APIs. One way you could do this, and Keith Gregory and I of Chariot are talking about this, is he recommended you could put an application load balancer in front of your REST engine, forward it to the existing REST engine, and one migration path is to start migrating your stuff to Lambdas, and for each one, make the mapping point to a Lambda over time. If that's possible, that is one way of moving to this kind of platform. And again, you can also respond to events in AWS. We'll see one of the frameworks is really good at doing this. But for example, let's say you wanted to run a Lambda whenever you added a file to S3, right? Loaded something to an S3 bucket through SFTP or something, some configuration. You could wake up the Lambda, do some processing on it. Transforming data in Kinesis is one way you do that. So you can say, as I put a message on Kinesis with one Lambda, Kinesis can trigger a transform, which could be another Lambda, which could turn it into Parquet format or something like that for a data processing engine. Executing a trigger on an Amazon DynamoDB database or something like that. All these things responding to a GraphQL query. There's this GraphQL API that they have, and in that GraphQL API, it allows you to either map it to Dynamo tables or just run a Lambda. So you can map a GraphQL query to a Lambda that you run in your favorite language that returns an object that gets translated to GraphQL. So there are a lot of options here. Now, serverless services, again, build for only when you consumed. They're not really serverless. We talked about this. I'm going to skip this slide. One quick thing is, though, they are usually accessed from the Lambda through something called the AWS SDK or some variant thereof. The AWS SDKs are language specific. For example, on JavaScript, there's one called AWS-SDK. It's an NPM install. On Python, there's one called BOTO3, BOTO3, and that's the library, that's the native library. There's another library called AWS Amplify, which is used for mobile clients and for single page app clients to connect up. So you'll have these SDKs, and these SDKs, one of the things they do well is they expose access to these serverless services. What if you want to do this manually? What would it look like? Well, first off, CloudFormation is a pretty verbose and tedious API. But I'm telling you now, if you're going to do anything with serverless, it's not just the infrastructure team that's going to learn CloudFormation. You should too. And it's simply because everything ultimately becomes something CloudFormation or something that CloudFormation outputs. So it's good to get used to it and learn it. I feel it's like the JCL or assembly language of the cloud because it feels that low level. But it is basically the low level configuration items that you will do. Each output of a CloudFormation command creates a cloud resource, one or more. Now, these things get deployed, these resources get deployed in CloudFormation stacks. A CloudFormation stack is just a collection of all these things. It gets run through the CloudFormation deployment tool, and it has a name. You can take a look at them. You can see what's in them. You can update them by pushing changes to them. You can drop them. And the other thing is that stacks, they can accept input parameters coming in. That could be pieces of other stacks. It could be the name of a Dynamo table or the ARN of something like an SQSQ in another stack. They can then output values if they're kind of that infrastructure stack, and they could do that as well. And stacks can contain just about any service you can provision in AWS. And realistically, CloudFormation is the basis of this SAM tool. It is used by serverless, and even Architect that we'll look at behind the scenes uses CloudFormation to get the job done. Here's a small snippet of CloudFormation. And actually, let me take you through a little bit more than that. So what you see here is you've got on line 1 there, that's highlighted with a bullet, you've got API Gateway. That's the name of something in CloudFormation. We give it a name. And then each named thing we're going to create, it's just the name that we're using in the CloudFormation script, has a type. And those types are all well-defined on Amazon's website. There's a resources, Amazon resources section of CloudFormation. It's an entire appendix. It's hundreds of pages long that goes into all the different types. Then they have properties, and those properties vary by the type. They might have variables that take substitution parameters like you see on number 3 there. There are special magic names, like when I deploy CloudFormation and give something a name, that name could be injected for the name of this thing, and so on. I'm going to give you access to a repository after this is done and the slides. And here is the infrastructure CloudFormation setup for that repository. Let me just do that 1 second here. There we go. So this is a shared infrastructure script that I used across both the serverless and SAM application samples. And what it does is it does the shared work of the infrastructure. And that shared work is a security pool for Cognito, the web access to it, a Dynamo table, and then outputting that information so that other stacks can pick it up. Now, I don't expect you to memorize the syntax, but realistically, that's an example of some CloudFormation that I still used because I needed to get some things done. And the best way to get a Dynamo table deployed, short of writing code for it, is to do it with a, right here, shared tasks table, like through this type DynamoDB table, and then it's done. This was deployed by running AWS CloudFormation deploy. Sorry for the light green there. And I gave it a stack name. I told it to assume the capabilities of my role to create this stack on my user. And I told it to put it in US East 1, and the template file was that file. So just plain old straight up CloudFormation. There's a good blog post by Keith Gregory. He's been doing a lot of blogging on Amazon Web Services. He's our AWS practice lead, runs projects for us for AWS. He has a blog post that's pretty recent called two S3 buckets, a Lambda, and infrastructure. And in that one, just one moment. In that particular blog post, let me see if I can grab this as another tab. Here it comes. So this is to create two S3 buckets, deploy to an S3 bucket, deploy the Lambda to an S3 bucket, create the Lambda, create all the permissions, set everything up. It goes on for a while. You know, the Lambda itself, the code we're actually running for these things is right here. Right, there's a Lambda. You can see you can even, as long as it's less than, I think, 2K, you can embed the Lambda in CloudFormation and deploy it that way. But a lot of this stuff is just infrastructure that's required. There's another Lambda. Is infrastructure that's required to expose the services, to let you upload things to them, to let you process the data in the Lambda. And so that's a lot of stuff, right? Hence, we need some sort of services. I'm leaving this here in the presentation just so you know these are all the things that you need to build a Lambda HTTP service. I'm not going to go over it. And you can see my little head banging thing there. Something is better than that. So for pure CloudFormation, I mean, the pros are that everyone uses it in some form or another in Amazon, except that they use Terraform, when there are a lot of people like that as an alternative. And you have complete control over any of the options you can set. And you can refer to stacks but from each other, and you can deploy the same stack over and over again. The cons are it's very verbose, right? It's confusing until you really learn it, like anything is, but it's pretty confusing. And every service has its own variations on things to do. Oh, sorry. Thanks for catching that. There. We just missed literally that. So sorry about that. So yeah, so that was to build a Lambda HTTP service. So hence I don't do it manually if I can help. You know, the tooling isn't great. You basically just have the CloudFormation deployment tool, and then you have the website. You can look at CloudFormation stacks on the website and manage them. You could use the Amazon CloudFormation command line to get things and compare them as well, but it's all pretty much command driven. So then we're looking at serverless deployment development platforms. What are our options here? So I have criteria for when I feel like I'm ready to adopt something and recommend it to my customers. It should be better than something else I want to recommend. So for example, whatever I pick should have a strong improvement, or at least a decent improvement to provisioning over just using manual, laborious CloudFormation. It should be well documented. It should have wide adoption, so when I go to ask for questions, I don't get silence or crickets, or at least rapid adoption. It should have some really good examples. You know, years and years ago, I did something called Power Builder back in my 20s. Very, very old person here. And Power Builder had the best examples of everything you'd ever want to do in it, and that's why people used it. You could say the same thing about a lot of other technologies that got a lot of adoption. It's because people documented how things work, and people had great examples of how to use it. And the biggest thing is it shouldn't add to the cognitive load of an already heavy cognitive load of learning the cloud. There's a lot there. No one tool has all of this. I like pieces of all of these tools, but I'm not sure that there's one that's the standout that I'm like, oh, tomorrow I'm using that tool. And that's what I felt when I ran into Angular. It had great documentation, AngularJS, I should say. It had great documentation for the time. It was really being strongly adopted. It had excellent examples out there. The examples were part of the documentation, and it was an improvement over doing things in jQuery. Many would disagree with me. And then beyond there, Angular and React and now Vue also are standouts for many of those same reasons. I'm also going to put this here. I'm not reading through all of this, but you want to learn certain things in order to be good at serverless. And so, for example, you need to learn the AWS CLI. How do I configure it? How do I connect it up? How do I make commands? How do I switch profiles to get to different accounts that I have? You need to understand how the accounts are built, know how to deal with the Amazon console. You need to turn on two-factor authentication for your console. You also have to have a basic understanding of users' roles, policies, and permissions, and CloudFormation skills and things like that. So I leave this here because it's just a good thing to kind of do a checklist on as you're sharpening your tools. Do I really know how these things work? And you'll be more productive if you do know them. So here are our three that we're going to look at. We'll start with Serverless SAM or AWS SAM. Okay, so SAM gives you helpful types. Remember we talked about those types earlier. Where in CloudFormation there were types for everything you build. For example, a Lambda function, right? That's a CloudFormation type. In serverless, there are types that are prefixed with AWS : serverless : and their name like Lambda, and they transform into more CloudFormation when they're deployed. So you don't necessarily see the thing that it builds until you go into the CloudFormation tool and then look at the resources that it created. But you don't see them in the original CloudFormation that you're building. It's shorter. So you get that. They give you a specific CLI for for SAM, because you'll use that to create the SAM project to begin with. You'll create it, you'll pick a language and platform like Python 3.7 or Node 12, and you'll say, go build me this shell project. And then you'll deploy and build and test locally with this SAM CLI. And you have the deployment command built in at SAM deploy. You also have local and cloud invocation. So you can run SAM locally, and it will run the Lambdas and communicate up with your client configuration to execute things. You also have the cloud invocation as well, so you can deploy to the cloud and run in the cloud. There are a bunch of other things churning out there. There's something called Local Stack, for example, and there's a number of other tools that let you emulate the cloud locally and run your functions completely locally to debug. I have not gotten that good at that yet. But personally, that's kind of on my list of things to work on and really tool up on. So now with SAM, your cognitive load is a bit reduced, because if you tell SAM to create you a Lambda, it's going to do the shared IAM role. It's going to grant execute authority to the role. It's going to expose the Lambda for the event you attach. If I say, give me an API gateway event, it's going to build the API gateway for me that I can override and change and modify, but it's going to build it for me. And so it takes care of it. And that means that there are dozens to hundreds of lines of CloudFormation code that you're not responsible for. But it still deploys those things, and you still debug those things, and you still need to go up and look at them. So the one place you'll look for this kind of thing is the CloudFormation console. And I'm just looking for my phone because I'm sure two-factor authentication has signed me out. Give me a second here. Yep. Okay. So I'm going to just briefly show you in CloudFormation what it looks like. So this is a Node.js platform that was developed in CloudFormation. I'm going to switch over to the code first. And if we look at SAM shared task app Node.js, the biggest amount of code is in template.yaml. And template.yaml is our CloudFormation stack. Now, normally you'd see AWS Lambda function and a bunch of other stuff in here. But what we've done by using the serverless stuff is that we've made it so that serverless will transform. And in fact, the second thing we have in CloudFormation here is a serverless transform. Serverless will transform any of the serverless named things into multiple objects. And so what we see here is we see a stack that is importing the identifier for a user pool for security incognito. We are asking it for a table name and the ARN. I think only I'm using one of these. And then we're also using the name we gave it when we deployed it, like dev, so that we can name resources that we're physically going to name for whatever reason. But the biggest thing here is that we're exposing a resource add task function that is a serverless function. And that's the thing where you see it build 4 or 5 things based on that one CloudFormation entry. And what it is, it's a serverless function that is stored within a file in this directory. Serverless will, SAM will upload that for you to the S3 bucket automatically and deploy it whenever you do SAM deploy. And notice it's running Node.js, so it's running on Node.js 12. And here are the Amazon events that we're responding to. And one of those events, add task event, we're only responding to one, is an API event. The API event is a API gateway REST service. So that's what we're responding to. The properties of that particular piece of configuration tell it, in one case here, we have the REST API ID. That points to the API gateway, and the reason I do that is because of Cognito security. My sample shows you a Cognito configured security for that particular thing. So I need to refer to that because the API gateway ties the security up, but you can skip that for the moment. The path I'm responding to is /tasks of whatever I deploy, and I'm responding to the post method. The other thing I'm doing is I'm telling the Lambda's environment, the operating system it runs on, to take the table name in Dynamo and grab it from the data passed into me as a parameter. Now the Lambda itself, it's actually going to look the same for both this one and for serverless framework. But let's take a look at that node add task. So this is the Lambda. I'm using here AWS SDK. I'm then also generating keys with the UUID node module. That's just a UID generator. And then I'm telling it to look up DynamoDB as a service. And from my operating system, grab the shared task table name. And it's the operating system of Firecracker VM that Lambda launches based on my environment variable that I placed right there. Okay, so that gives you an idea of kind of the mechanics of it. Then from there, you don't have to really read this too well, but I'm basically throwing some defaults in here for testing on this particular copy, but I was working with the event. If you wanted the input, it comes from event.body, and you can get the body of the event, and that'll be all the parameters sent as JSON. I think in the other one, I do that. But anyway, I'm just making up a fake item for testing here. I'm putting the item, and then the only reason this thing is complex is because of cores. And I will just say this, one thing you will wrestle with a lot if you're doing single page applications with serverless is you will wrestle with your security a lot. And you will have to really struggle with it. I tried to give you a working example with Cognito serving the security and providing you an endpoint so that your application could connect to it, but they're on different domains. So I had to set up cores. So what you'll get with this repo is a working cores config with a working Cognito config. And hopefully that helps you. But you basically have to send back the headers and say, yep, here's my response. And by the way, I'm allowing these this cores app to read my response. And it's, probably not the best written Lambda in the world, but it serves the purpose of the demo. We also have one, if we go back to our template here, for list. Same exact code. We're just mapping to get on tasks, and we're pointing to a different Lambda in our project. Okay, so there's my same thing. Now, in addition here, we are doing the DynamoDB query operation. And on the Amazon SDK for JavaScript, there's a .promise. So there's a callback version. This is default, but you can grab promise on it, and then you could do async and await on that if you want to. And that's what I'm doing. So that way I don't have to write I don't have to write big, long promise.thens. I just use async on the method and await to look like I'm physically waiting on that line, but I'm just basically generating a callback, a promise callback. All right, so now all that, what it built was it built all these resources for me. And you'll see we have our add task function. That's an AWS Lambda function now. Let's see if I can make this larger. There we go. And then I've got an AWS Lambda permission. I didn't build that. A role, I didn't do that either. I have my other function, permission. One thing I did do is I defined a special API gateway instance, and that was because I had to because of Cognito. And that, they actually mount one for you by default. So if you didn't do this, you would get a default plain vanilla API gateway with no security setup. But I needed it to have cores configuration, and I needed to have an authorizer, and an authorizer connects you up to a security engine. The authorizer that it will accept for Cognito is the user pool. I also think you can send it the identity pool as well if you want actual identity and rights. All I cared about was login in this case. But this line right here allows me to connect to Cognito through an authorizer. And the authorizer is Cognito, which is the security system's user pool. It's the thing that is the security system, kind of like an LDAP resource, if you want to think of it that way, or OAuth resource. And then that plus cores made it possible for me to connect in my client. That's probably as far as I can get based on the time constraints we have because we're running short on time. But let me continue here. So one thing I'll tell you is when you use SAM and serverless, and in general, you're going to have some things that aren't changing that much. Your security mechanism, your databases, put them in separate CloudFormation stacks. I wouldn't try to make your application deploy those because you don't need to deploy them nearly as often, maybe in the beginning, but then when you get to production, you might deploy it once and never change that for 25 changes to your application. So there's no reason to try to deploy that at the same time. You can, but you probably don't need to. Avoid explicit resource naming. The reason being that in a, if you name a resource where it physically has a name or an identity, if you deploy it more than once, it's got to have something unique in its name. So you need to put the stage name in as part of it. If you're doing like a URL, a domain name or something, an S3 bucket name, you're going to have to make something unique about it in that same availability zone and region. So those are the big things there. Link your stacks together through exporter resources. Keep in mind, SAM sometimes doesn't detect stack changes, so you may need to force your deployments. And some of these serverless types lack some significant documentation. There's a lot of searching through forums for things like cores that isn't going to change when we look at these other things, unfortunately. But even with the documented ones, some things are confusing and need a lot of clarification. The pros are that your types can save you a lot of time and provide defaults for Lambdas for API gateway or a table. There's no new syntax really. It's just CloudFormation with special property names and titles. And the tooling is a little bit better because you can do things like view logs and deploy things and things like that. But you're mostly on your own for CloudFormation syntax, and local development can be challenging. All right, I'm going to keep moving here because I want to cover the serverless framework. Now, the serverless framework was called JAWS in the past, but serverless is a framework that tries to be cross-platform. And it tries to be cross-platform by providing the same domain-specific language in YAML across different platforms and the same tool across different platforms. But it transforms them differently based on the provider you install. So we're going to use the AWS provider. It provides a cross-cloud monitoring platform for free. Certain things cost more money. Certain types of operations, like some of the CI integrations and links to Slack, require a license. But that's one of the benefits is you've got this dashboard system that you can use, and some of it is free. And again, on AWS, it's still going to transform CloudFormation from its DSL. So you're going to see CloudFormation in some places. You're going to see serverless domain language in some places. They all turn into CloudFormation in the end. And it's not really a leakless abstraction. Each of these different things, when you go to a different cloud, has different mappings. And it does not use the SAM transform classes. It just uses the straight up CloudFormation ones. So let's look at an example of that. If we take a look at serverless shared task app, same basic thing. Here's a serverless entry. So now you'll notice that we don't have types here yet. We just have these special names like the service. This ultimately is the name it gives it, and it tacks on the stage you deploy to, like dev or test or production. The provider is, what am I targeting in terms of like its actual output? So my provider is AWS. The runtime in AWS is Lambda Node.js 12 runtime. The stage I'm deploying it to is dev, so dev gets tacked on there for the name. This is the region I'm using. I can parameterize that if I want to. Here's my environment variables. What I'm doing here is I'm actually using function import value. That imports a value from another stack. Just real quick, you can do this, and you don't need to do this from the serverless framework. You can do this from regular old CloudFormation. But at the very bottom of my infrastructure CloudFormation, you'll see I have exports. So each thing I output has an export. Those have to be unique in your region. And so when I deploy, hold on, I lost my, there we go. So when I deploy, I can then import that value from the same region and look it up and grab the things I need. I'm doing something like that in scripts for my serverless SAM, but in serverless SAM, the Amazon tool, I had to use a shell script and the CLI to get that information. I probably should have used function import value. But anyway, now you'll see I've got a special DSL for IAM roles. I see a special section for functions. Now notice a lot of the IAM role stuff, it's the same stuff. I need to know IAM roles. I can't get away with not knowing it. Right? So I need to know CloudFormation anyway. So I'm saving some, but I'm not saving everything. That's something to keep in mind. Here are my functions. I'm creating an add task. The HTTP event type is an API Gateway version 1 event type. And you'll see basically almost the same stuff in here. I'm using an authorizer for my Cognito authorization. And there's a type here that says I'm using Cognito that they need for whatever reason. But I'm basically responding to the post and the get. The Lambda is identical. No changes to the Lambda code at all. Here's my resource to mount my authorizer. So there's a little bit of work to do that's a little different there. So I'm building an authorizer, and this is because this is supported by serverless as a way of mounting authorizers to apply. It's its own little kind of configuration, but I'm basically doing cloud formation here. See that? I'm building an Amazon authorizer, and then I'm installing it in the REST API, basically. So that's serverless at a high level. You know, the command to deploy serverless is serverless deploy. You give it a stage, and I'm using force to always redeploy it each time. So not a lot different there, except for the DSL for serverless. But the other thing to keep in mind is that the serverless stack here, you could import a file, which is pure cloud formation. I'll make sure I tweet some links, and I can put them in the forums when we're done here, for a really good serverless tutorial from serverlessstack.com. It's excellent tutorial, goes through a lot of different things, and I used it for some of my learning. And they do a lot of cloud formation from resource files that they import into serverless. All right, so let's review that now. So the other thing I want to point out is they've got plugins. I didn't use any of these in this project, but I've experimented with a fair number of them. There's one for emulating Lambda and API Gateway offline called Serverless Plugin Offline. There's one for tracing called Serverless Plugin Tracing that lets you do X-ray tracing with not a lot of extra work. X-ray is like the low-level cloud tracing tool. Serverless Finch is really great if you have a single-page app and you want to put that in your project as part of a monorepo. You can then tell Finch where your distribution directory is, and you can say serverless Finch deploy, and it will push up to the S3 bucket and serve your web server. And then all of a sudden, you've got a React client in the cloud. It's great. And if you're doing Python, you want to look at serverless Python requirements. When you install that plugin, it looks at your requirements.txt file for your dependencies. So syntax is just different. I almost recommend, and I think I would recommend that someone learning serverless goes through the work of doing a full SAM project first, or at least does that on the side to pick up all the details they'll miss by what serverless does for you. Mention cores. There are magic components that got created. So for example, the API gateway, like I said, gets created by default the minute it sees an HTTP API. So the minute you see that, it creates it, but you can mount your own to override it to change things like setup security. So the serverless command has a shortcut SLS. So if you type it, you can save a few keystrokes. You can not remove a stack if you have syntax errors in your serverless file. So commit all your changes, and if you really have to drop something, roll back to the good committed one and then drop the stack, I suppose. Or go into this AWS console and manually drop it, which can be tedious but can work. And if you want to see what serverless generates to send off, you could do serverless print, and that will print what your DSL turns into, which is really useful. So from the pro perspective, if you're working in multiple cloud environments, that's one provisioning tool. That's kind of nice, but there's not a lot there really. You could do the same thing with shell scripts. So I question really whether I would take this and use it in first of all, would I do 6 different cloud platforms? I wouldn't. But I don't know if I would jump to serverless for every one. You have to see how the providers work for each one, and I don't know. So I'm not really qualified to answer whether that's great or not. You can still use CloudFormation, and you will, either separately to build up your infrastack or as part of this because it's easier to do some things. Maybe the DSL isn't there for some new Amazon services. The plugins are great. They're the biggest single great thing about it. The second biggest single great thing about serverless I want to show you, I'll do it for 1 second, is the event model. Their event model, if you need to do anything, let's see. All right, I can't find it now. But if you need to attach serverless to like a queue or an S3 bucket, they've got all the events have a special. There's like 20 of them. There are special event names for attaching to different types of events from Amazon. So they're really, really great. But the DSL is going to add cognitive load to CloudFormation. So learn CloudFormation first before you tackle serverless. Then you might find that it's a better experience. The tooling for it, like IDE tooling and such, is hard to find. I haven't found a good fill-in feature that works. It's kind of out of date. And the plugins, keep paying attention to those. They might rot. Pick the ones that are really commonly used and keep track of them. Also, if you're experimenting with the API Gateway v2 support, it's kind of questionable. I'll also point out that Drew DeCarme, who's one of Chariot's consultants, an excellent React developer and CSS developer, he used serverless on his application deploying to Cloudflare, and you'll get that with this PDF as a link to it that you can take a look at. The last one I'm going to use, all I'm going to say about it, I've got 5 minutes, so I'm going to go with this, is Architect. And I had such a good time with Architect, and with the support I got from Brian LaRue from the Architect team on their Slack over last week. In a day, I had an application up and running in Amazon with Architect, and it was easy to work with. For what it does it really well. It gets rid of the problem of huge cognitive load. And that's why I called it serverless Schmerverless. So I'm going to skip all these slides. So it's an abstraction of a Lambdas and serverless and also Dynamo and queues. And it's for building applications so you can focus on the business logic. So like single page applications and things like that with a REST backend. It's great for that. Is it good for doing all the other stuff that serverless and SAM do? Probably not, but that's its goal. Kind of think of it like a Rails or a Django. So it's not a general purpose platform, and it doesn't make it easy to integrate with real cloud formation stuff. At least that's not documented well. But I will tell you that because of that, how much good I got out of that talk, I provisioned a talk for tomorrow for Brian LaRue. So you can head over tomorrow on Wednesday. I forget the time, but there's a talk by Brian LaRue on Architect in depth. So if you wanted to pop off now, you could, but here's an Architect configuration. This is an application. The first 3 things I have there are just pro forma, and I'm playing around with macros, and there's nothing happening there yet. But I'm telling you what my AWS config is. I'm creating a landing page and tasks, get and post. And I'm telling it to build a Dynamo table with a task owner and task ID in it. The Lambdas are different. They actually have, so for example, I hear someone talking to me. The Lambdas have kind of their own boilerplate. But there's the Lambda for serverless, for Architect. They give you an API for database access, and they make it relatively easy to work with. Here's the post. So they have a data API. They also have an API for queues. You could do @event, and it will create an SNS queue. Or you could do @queue, I believe it is. Many other things. So bottom line, Architect is definitely something you can use to build apps quickly. And if you want to see it, tomorrow at 1:30 p.m., there it is, with Brian LaRue. Less but better serverless with OpenJS Architect. I've got a bunch of stuff that I'll give you on the PDF that I knew I wouldn't get to. Lots of tips and tricks. So final thought, SAM's most long form and native AWS platform. Serverless is powerful and great for quick attachment of Lambdas to Amazon events. And Architect is a rapid development tool for AWS. It might be the best for quick applications without learning a lot of external dependencies. And I will hang out in the chat room after this talk. And that's it.
Yeah. I just want to let you know, Ken, I actually created another Slack channel called Serverless to kind of continue the conversation there, so you guys don't get confused with
Jack,
everything kind of going on in Room B. So you can take your questions there. Thank you, Ken, so much. I'm not sure when this video is going to self-destruct. So
now, or my car will catch fire with all the wires in it. Thank you, everybody, for being there. I'm sorry I didn't have questions answered, but we'll do them on Slack, like you said.